All right, let's move on and look at a couple of applications using quadratic functions. So looking at problem number 12, it says a ball is thrown vertically upward. After t seconds, its height in feet is given by h of t, which is equal to 80t minus 16t squared. So we have a quadratic function. So I want to make note of this quadratic. All right, so we see here on this problem that our a value, a is equal to negative 16, right? Coefficient of our squared terms, less than 0. So that implies what? Parabola opens down. So if I was drawing a quick sketch of this quadratic, right, model, here's what it would look like, right? So this is this quadratic they're giving us. And right here would be the vertex, right? That point here, t, h of t, right? So there's the vertex of that parabola. Vertex, which equals our max point. All right, so again, t is the x-coordinate, and ht is the y-coordinate. So again, ask us the question, when will the ball reach its maximum height? So again, we've got the path at which this ball takes as it's thrown up into the air, right? It's going up, gravity's pulling it back down. So you can see, again, a picture, right? Here's the ground that we're standing on, and the ball goes up, and it comes down, right? With that said, we want to find the maximum height, which is our vertex. So we need to find the vertex. Right? Find the vertex, right, which is equal to your max height, right, location. So with that said, let's find that. So to find the vertex, we'll use the vertex formula. So again, the vertex formula says the x-coordinate is calculated by negative b divided by 2a. So in this problem here, we've got a b value, right? Here's b. b is equal to 80, and a is negative 16. So we got negative 80 divided by 2 times negative 16. So we plug in our values of a and b. And as we simplify, I got negative 80 divided by negative 32. So let's go ahead and calculate that. What's negative 80 divided by negative 32? It gives us 2.5. All right, so what does that say? So that's t. So that implies after 2.5 seconds, the ball reaches max height. All right. Now, what is the max height? Now we got to find max height. So that implies what? We got to find the function value h, the height function, at an input of 2.5. So at 2.5 seconds, achieves max height. So let's go calculate that. So that'll be 80 times 2.5, 80 times t, minus 16 times 2.5 squared, right? Minus 16t squared. As we do that, let's go ahead and plug that in our calculator. Let's simplify a little bit. 80 times 2.5, I get 200 minus 16 times 2.5 squared. Well, that's minus 16 times what? 2.5 squared is 6.25. All right, so that's equal to, let's simplify down further, 200 minus 16, right, times 6.25, right, and I get 100, right? So there it is, there's 100 what? And this is in feet, it says. So there's our max height, 100 feet equal max height. There's the y coordinate, right? So we're finding the vertex, right? The vertex, again, tells us everything with our quadratic. Allows us to get our sketch, right? Gives us our information. So there's that ordered pair, again, 2.5, 100. There's that ordered pair there. So with that said, we've got our two answers. So it wanted us to know, when will the ball reach maximum height? So 2.5 seconds reaches max height. And then part B, of course, wanted to know what its height is, 100 feet. Right. So pretty straightforward application, right? That was modeled by a quadratic. The path of that ball as we threw it up in the air, right? It's thrown vertically up into the air. We see it takes that path there of a parabola, that parabolic path, which is our quadratic function there that describes that path there.